Integrated 3 students that are distance learners, we are starting our new unit, and as you can see I have a new overlay that is around my screen, so that's a nice little fresh update for this new unit. Was watching a streamer and I saw theirs. I was like, you know what, I could do that too. So I may change it up from time to time, but just something a little bit different to get the videos started, and if I want to talk to you guys just with my view and me talking. So we are starting the new unit, Unit 3.1, and if you would, in your notebooks, you need to go ahead and start a new page is what I would recommend, and you're going to title it Unit 3.1 Rational Expressions and Equations. Now, this is going to be pretty quick. This is a little bit faster than the past few units that we've done. We've typically tried to keep it every 2 weeks. This one's going to be like 1.1 weeks, 1.2 weeks. So like maybe a few days of instruction, but it's pretty quick. Okay, so this should be pretty good. There should be Delta Math up for you to practice with. We're going to be looking at some of those examples today. So I'm going to go ahead and have that ready for you. But let's talk about what a rational expression actually is. So let's start with this. What does it mean to be a rational expression? Well, in the word you see ratio. Okay? That's sort of the key. When you hear the word rational moving forward in your math careers, you need to be thinking of this idea of ratio, which is part to whole, part to part. Really, what we need to be thinking about is a fraction. Okay? So that needs to be your mindset. Dealing with fractions, which a lot of students really don't like dealing with fractions. They can be very complicated. And honestly, if you had a tough time with them in, say, 5th or 6th grade, that sort of carries over into high school. Obviously, if you don't have a strong foundation, that can be difficult. So obviously I want to help you guys understand fractions a little bit better in this unit, but we're going to start with an example that you may have seen in, say, middle school or even before. Maybe not. These are pretty large numbers that we're going to be dealing with, and we have this ratio right here, this fraction. Okay, so we're going to do 254 divided by 86. All right, so here's your instructions. I want you to simplify this. So I'm going to pause the video. You are going to, in your notes, try to simplify this on your own. Okay, so there's so many ways that you can do this. And at this stage in your math career, a lot of times we let a computer do it for us. So for me, if I have my Inspire or my TI-80, there's ways you can do it on there. I'm taking 254, and I'm going to divide it by 86, and the calculator spits out a value for me. Oh, hold on, no, I changed this. Not 254. All right. Let's do another one. So yeah, if you got that, that's correct. Whoops, I actually changed these numbers. I changed both of these numbers, holy cow. All right, good job if you got that. Perfect. Example 2, here we go. We're doing another. Okay, so we're gonna do 256 over 88. That's what I want. Okay, pausing again, here we go. All right, so let's now redo this. I'm going to copy and I'm just going to change these numbers, 56 over 88. So this is how a lot of you, again, like the last example, would do this. There we go, 32 over 11. Okay, so obviously that's not the skill that's going to be taught to you guys. Okay, because these are the question types that you're going to receive. Okay, so we're going to have 20x to the 6th over 14x squared, right? And while I think a lot of you could do this question, there's still, like for some of you, as soon as variables get thrown in, things get a little bit more complicated, right? It's not just numbers, and that's been, since you first learned what a variable is, you may have felt that way in math. So let's talk about another way. We're going to work these side by side. Obviously, we know the answer. The final answer should be 32 over 11. But if we wanted to do this without a calculator, without any help in that way, and that's the goal with this unit, we don't want computers doing this work for us. We need to make sure that we're able to do the processes by hand, only doing simple multiplications and divisions, additions, subtractions with a calculator if we need to. But all of this should be done by hand. So how can I rewrite this is what I want to know. Okay, what is an equivalent way to write this? Well, what I want to do is I want to break this down into I'm going to call it its prime factorization. That means the only thing that I want to show are all the prime numbers that multiply to get it. Okay, so I'm going to write, we're going to write 8 2s. So go ahead and do that with me. So 1, 2, 3, 4, 5, 6, 7, 8. Because 8 2s will multiply. Watch if I do, let's do 8 to the, 2 to the 8th power. Let me clear that. Hold up, I've got all of this wrong. Okay, 2 to the 8th power, 2 times itself 8 times, I get 256. Okay, so that's the prime factorization. All of those 2's will multiply. Next, I'm going to do 2 times 2 times 2 times 11. That's going to get me 88. So I now have this broken into its prime factorization. 2 times 2 times 2 is 8 times 11 is 88. Now you don't have to do this to simplify fractions. I'm just giving it as an example because it's going to help us here. From this point, what would we want to do? Well, we want to divide away as many of these 2's as we can, and that leaves 5 on top and just the number 11 on the bottom. Well, guess what? 2 times 2 times 2 times 2 times 2 is 32. 11 just stays 11. There we go. We simplified it. Okay? Now, another way that we can do this is we can find the GCF. What is the GCF of these? Well, we've factored away 3 2's from the top and the bottom, so the greatest common factor would be 3 2's, but what does that equal? What's 2 times 2 times 2 in the calculator? 2 times 2 times 2. That's 8. So we would say 8 is the GCF, and that is 8 times 32 equals 256. 8 times that is 88. Then we cross them out. That's a faster way to do it by hand. Okay, factoring out that GCF. All right, so that's sort of the mindset we want to be in when we go to approach these problems down here. Okay, we always want to, we're going to write some steps. We want to factor. Following these steps is going to help you so much in this chapter, and if you do this, you're going to find so much success. Okay, so let's go ahead and do this. Let's factor. We want to find the common factor, obviously, but I'm going to do what I did up here. I want to find the prime factorization. So 20, that's 2 times 2 times 5. 14 is 2 times 7, right? These are prime factors. And then what about all these x's? Well, I could rewrite those like this. X times x times x times x times x. And right down here, it's times x times x. This is too much work, honestly. Okay, so we're going to find ways to speed this up, but this is just to explain sort of what we have to do. We are trying to factor the top. So I'm going to write that. Factor, we're going to say not just factor, but factor the numerator and denominator. Okay, we've done that. Now, what are we looking to do? We're going to say divide away. That's the proper way to say that. We don't want to use the word cancel out. We're going to say divide away common factors. Fan has got this paper going crazy. All right, so I'm going to start crossing through the common factors where these 2's are common factors. These x's here, these x's here. I'm just going to start factoring, dividing them away. Oh, you can't see my text there. Okay, there we go. Divide away common factors. I'm going to start dividing those away. And then what's left is 2 times 5. I have 4 x's on top. And then just a 7 on the bottom. So this gets me, we want 10 x to the 4th over 7. And that's going to be the right answer. Now, could we have done this faster? Absolutely. If I'm looking at this question, so let's work it another way. 20x to the 6th over 14x squared. What is the GCF? Well, it's 2x squared times, and this will be 10x to the 4th. So we've done GCF in this class already with factoring. Up here it's 2x squared, and that gets me 7 on the bottom. These divide away, and now I have my answer. So for those that have a really good understanding of this, this is how you would answer these questions, okay? But I would say, and I think you've done this in iMath 2. I don't think that this is brand new. But in iMath 3, we are going to be doing more complicated examples. Okay, so I'm going to go ahead and let you know that it is going to get a little more challenging. Okay, so let's go ahead and look at another example. All right, so we have this example here. We have binomials and trinomials. Okay. Now, the steps remain the same. We're going to keep the exact same processes, all right? But now the idea of factoring becomes a little more complex, okay? Factor the numerator and the denominator. Well, now that we're dealing with polynomials, we have tools to do this, okay? I'm gonna write four bullet points. This is what you should be looking for. You should be looking for GCF. You should be looking for quadratics. You should be looking for difference of squares. You should be looking for factor by grouping. We called this I called this the Factoring Toolbox because that's what you've developed this year. Assuming you've done all of your work genuinely, you have developed these skills. If you have not developed these skills, but you got 100% on the factoring unit delta math, then you have cheated yourself. Okay? And you will have to continue that effect of doing work dishonestly to answer these. Again, a computer can do this work. All right? And I'm not trying to put ideas in your head, but if you are going to work these problems and let Google do it, you're cheating yourself. And when you take ACT, you're going to lose out on money because you decided not to do it honestly. Okay? So keep that in mind as we're looking through this. All right. So here we go. The first thing we want to do is factor. So here we go. I've got my toolkit, GCF, quadratics, difference of squares, factoring by grouping. I'm going to look at the numerator first. Can I factor this using any of these techniques? GCF, no. Y plus 8, there's no GCF. Is it a quadratic? It's not a quadratic. Difference of squares, there's no square. Factor by grouping, there's not 4 terms. The top is going to stay the top. Okay? Y plus 8. Now, what about the bottom? We're going to try this. We're going to try the factoring techniques on the bottom. GCF. Is there a GCF all 3 terms? No. Quadratic. Is this a quadratic? Yeah, it's a trinomial quadratic. So I'm going to draw in green. We're going to do the work for this, which is going to be, we're going to have y squared plus 2y minus 48. What's the factors of 48 that add to get, it's negative 48, add to get positive 2, so 1, 48. 2 and 24. 3 goes into it, right? That's 16. 4 and 12, and I just like to list them all out. Okay, 6 and 8. Okay, that seems to be the ones. It's going to be a -6, so we get x minus 6, x plus 8. All right, so we did our factoring. X minus 6, x plus 8. Also, these are not x's, these are y's. But that's not going to be a big deal as long as you know, like on a test, that the variable is different. That shouldn't be a problem. So, but these are y's. So this is y and this is y. All right, so now, can I factor this any further? Again, we're analyzing our tools over here. We're saying, what factoring tool could I apply to the situation? GCF, no. Quadratics, no. Difference of squares, no. Factor by grouping. We're just trying to simplify it into its simplest parts on here. And just like we did up here, we're trying to just factor it as much as we can. And I can't go any further. So now we're ready for step 2, which is divide away common factors. Okay, so here we have common factor. You'll notice usually when there's a term by itself, I like to put it in parentheses. And you'll notice we have y plus 8 and y plus 8 that are the exact same, and they are going to divide away. So this is sort of the fun part. Once you get all the factoring done, you can just start crossing through things to show the division. This is not canceling out. Students always say, hey, this is canceling out. We're not going to call it that. We got to use the proper language for this. It's dividing away, because what happens is when you say the word cancel out, students get very confused about what goes up here. When I say the word dividing out, when I divide anything by itself, these y plus 8s, what do I get to go up here? We should be saying, oh, 1, right? The number 1. And this is the correct answer for this problem, okay? So that's sort of the step process for what you want to do on these questions. So we're gonna work another one, and then we're gonna look into some delta math. But these examples, they can get pretty wild, okay? I keep calling this class polynomial gymnastics. This is another aspect of those gymnastics that I talk about, okay? So here comes another example. This one's gonna have more to it. So we have 2r squared minus 2r minus 40 over 8r plus 32. Step 1 is to factor. Let's start with the numerator. Can I use GCF up here? Is there a common factor between all three terms? Hopefully you see that there is, and we're going to pull a 2 out in front, and we get r squared minus r minus 20. Okay, so that's going to be sort of our first phase of factoring. We'll continue in a second, but let's just go ahead and do the bottom as well, see what we can do down there. Okay, is there a GCF here? 8 and 32, yeah. The GCF is 8, and we get r plus, what's 32 divided by 8? That's 4. Okay, now can I do anything else on the top? Go through the list. What are our tools? GCF. Well, I've already done GCF, so can I do a quadratic? Is it difference of squares? Is it grouping? Well, we see we have another quadratic here. So we need to factor that negative 20, which is going to be 1 and 20, 2 and 10, 4 and 5. 4 and 5 are going to add to get 1. There's a 1 here, but we need one of them to be negative, and it's going to be negative 5 and 4. So we're going to rewrite this like this. 2, we want r plus 4 and r minus 5. We're going to put that over 8 times r plus 4. So I kind of, okay, so now we're on step 2, which is we're going to divide away. So what all can be divided away? Well, we have common factors of r plus 4. And a lot of times, students get this pretty quick. We start dividing that away. We can divide the whole term, by the way. We're dividing whole terms. But But now we have these 2's here, the 2 and the 8. They are actually common. They have a common factor, which is 2, right? So we can actually divide these, and we're going to get r minus 5 over 2 over 8 becomes 1. I'll just put the 1 there just to show it, over 4. And there's nothing else down here. This question's over, so it'd be r minus 5 over 4. This is what I would put, say, in Delta Math or type in, because that's all it would really want. I don't think it would count off if you typed it like this, okay? So that's the idea. We'll look at some more advanced examples in another lesson, but I don't feel like I need to continue except for this. Let's write down common mistakes. If I had an expression like this, 6n squared plus 8n plus 2, so here's our common mistakes here, divided by 2n squared minus 2. Oftentimes, students will divide away these terms here. And they would put this. I'm going to put not equals just to be clear that this doesn't work. They would also divide these with each other. Okay? I'm going to draw little arrows. They would divide those away. And they may say, oh, the answer is 4n squared. 8 didn't have anything, so that's just going to stay 8n. And then this is just going to be minus 1. This is not correct. You can never, okay, never divide away expressions separated by addition or subtraction. Another example, r plus 1 divided by r. This is not equal to 1. Students will try to do this all the time where they just start dividing these away. Why can I not do that? Because it's separated by addition. Okay? If this was 3r over r, yes, this equals r. This is correct. Okay? But that's because it is separated by multiplication. This is such an important rule that you need to remember. You can only do, let's go back up to the worked examples where we had it correct. I could only do this because all of these, see these green dots? All of those are separated by multiplication going up. I could only divide away these terms in the simple examples. Let's even go up to the number here, because they are separated by multiplication. If it had been addition, I couldn't do it. Okay? Here I could divide them away. And then in this example, or no, that's the same example. I could divide these away because they're being multiplied. Here, this is being multiplied. I can divide those away, but I need the whole term. I couldn't just do the y's because there's an addition sign. That's the rule that is so important. So many students mess that up all the time, and it hurts them on ACT. So hopefully this common mistake, and I'll just say mistake, that's really the big mistake. This common mistake can be helped by this video, okay? So we're gonna go ahead and stop it there. Hopefully that's good. Oh, actually, no, I said I was gonna do a Delta Math example, so let's look at what that is gonna entail for you. So far you only have 1, 2, 3, 4, 5 sections. So if we're looking at this one here, let's just work one real quick. These are going to be trinomials only, which means the factoring technique you need is quadratics. There's not really, you're still looking for other factoring techniques to use, but we're going to go ahead and start with this negative 20. So that's 1 and 20, 2 and 10, 4 and 5. And I can tell that negative 10 and 2 are going to be the factors I need for the top. So we factored that, so it's x plus 2, x plus 2, x minus 10. And then on the bottom, we're going to do the negative 50. We're going to break that apart. We want 1 and 50, 2 and 25, 4 3, 4 won't work, but 5 and 10 will. And that seems to be the numbers I need. So it's a negative 10 and positive 5. So we get x plus 5, x minus 10. What in the 110? Minus 10. Okay, there we go. Now we're going to divide it. So we factored. Can we do any more factoring? No, we cannot. Now we're going to divide away common factors. The whole thing gets divided away. So my answer is x plus 2 over x plus 5. Let's go to Delta Math and check that out. So x plus, so we're going to use a forward slash on your keyboard. What did I say here? X plus 2 on top, and then x plus 5 on the bottom. Just double checking. Yeah. Submit. Always on stream here, or on this video recording, it takes forever. Maybe I need to refresh. Let me copy. Oh, it worked. Okay, perfect. That's how you'll want to do that. Also, this one, simplifying rationals, you have more advanced techniques. So up top is a difference of squares. Let's do a new problem. GCF up top, quadratic on the bottom. So you're just using all the techniques of division that you know to help simplify these as much as you can, okay? The only issue that I have with Delta Math right now is they don't have any factoring by grouping examples, which is a real problem. So I'm gonna have to figure out a way to incorporate that. So there might be an additional assignment that comes out. All right, we're 26 minutes in, we're stopping. If you have questions, let me know, okay?